Yeah, so we did say we won't be doing live coding this time, but by all means, if you want to change the name, in case you've not been doing so, create a new Google Colab project or notebook, and also make sure you use a meaningful name at the top there. And we just want to try out some k-means clustering example. You already have access to your data set, and the problem statement this time is basically to make use of that data set that I've given you. Just try to do some market segmentation, right? So we just want to do some market segmentation similar to the example we use in the slides, but I've written some stuff on here, and that's just a bit of notes. But our target basically is to know how to import and explore and prepare data for k-means clustering, how to segment the data by k-means clustering, and also evaluate and visualize the clusters, and also the stuff we just talked about, which is basically how to choose the appropriate number of clusters and also analyze the results. So please start off by importing the libraries. You should be a bit familiar with these libraries by now.
Yes.
So mostly you want to import pandas, you want to import NumPy, and you want to import Matplot, Seaborn, and OS. Do you want me to zoom in, or you're okay? I think someone else is online.
Okay.
For the benefit of the person online, maybe I'll
I think you're fine.
put some things in the chat for the person. But it's easier, it's better if you type yourself though. So I think the first two steps, very similar to everything, what we always do. If you go into your drive, of course, import drive, mount the drive, and the ls command help you to see the contents of the directory once you get into it. And if you find out, in my case, I have more customers.csv, and also I've got another one, and also I've got the old ice cream data in the same folder. And we are interested in using the more customers into a data frame. So it's a pandas data frame. So we just use pandas to import it into create a data frame called customers in this case. And of course, you can call it training sets like we did in our previous lab. So where I've got AI, remember, you are replacing that with your folder name, okay? So if you called it my folder, it's going to be your folder. And however you've named the data set in that particular folder, that is what you also want to end up with. Are we okay up to this point, or should I pause a bit?
We're fine.
Okay, I can continue. Or... Have most of us managed to mount and then also connect the data?
Yes, please.
Okay. So once you're done, normally you just want to have a peek into the data set to see whether, of course, it will just a quick inspection to see it's the right data that you've got, and we've got a head. If I want to print the first 10 elements, what should I do to this line of code?
You add 10 to the head.
Add 10 to the head, like that?
No, please.
Right, to type 10 in there, right? It's an argument. Okay, good. So I'll take it as we are okay up to this point. Should I zoom in, or you can see clearly?
Oh, we can.
Please zoom in.
Okay.
Is it better?
Did you change? Oh, yeah.
Can you please do it again?
More?
Yeah, it's okay.
Okay. I feel like I'm looking at my screen with goggles or so, well, with an magnifying glass. Right. Let me know if you want me to continue. Somebody please say continue because I'm waiting. Otherwise. Asking you okay for us to continue, yes? So basically peek into the data show us that we've got gender distribution, we've got age distribution, we've got income, and then we have spending score as well. So pretty much similar to the stuff that we used as an example in class. So next step, as we all know, is to explore and visualize our data set. So let's get the concise summary of the structure and also the values within our data set. So to do that, you can use the info. Let me send it across for those who are online or in the chat. So you use info to inspect or just have a quick view of the data. You notice with info command, we can tell that we've got about 200 entries in our data. And also we have 5 features where we have the customer ID, we've got the gender, we've got the age, income, spending score. We can also tell that the gender is in text format, and then the other features are basically numerical data that we can deal with. So just give us a good indication of what we're working with. If I scroll too fast, please just ask me to go back, okay? Yeah, so then we make use of, you've all got access to Seaborn, of course, so we make use of Seaborn, and then, oops, what is that? Sorry, let me cancel that. And we want to make use of the Boxplot, right? Luckily, we get these features that allow us to use color combination that are friendly to color blind people. Sorry, let me bring it down so at least you can see. Boxplot, we've used it several times in the past as well. So basically, we just want to visualize the data. Let me put that in the chat. But by all means, please type it yourself. And we notice from the Boxplot, the first Boxplot we have, we just simply looking at the gender and we're looking at the income. Hello.
Can you please scroll back up and please slow down a little bit?
If you say stop, then I stop.
Yeah, stop here. Thank you.
Okay.
Okay. So I think you can proceed from here again, but just a little slower.
Oh, I can proceed. Okay. I mean, this bit is just an output. You can generate it yourself. So it's just simply customers.info. That's all with that. To get just capture an overview of the data that we're dealing with, right?
Right.
Continue. Pause.
It's here.
I can continue from here.
Yes.
Okay. Those online as well. Online, I'm putting the codes in the chat as well. So those who are logged in. As long as your bandwidth, you don't freeze the bandwidth, we're okay. So basically, we're just doing a Postplot from Seaborn, and we're looking at the customers for each. That's the data frame we've got. We're plotting gender against income, right? So put it there for the benefit of the last person who just joined in. And we notice from the distribution of gender against income is in terms of the earnings between male and female, they are really quite similar. There's not much difference between the earnings of the male and the female. I'll pause there for a bit, just breathe, for those who are still typing. And then as soon as you're done, somebody give me the green light and we continue. Just simply say continue.
Okay, I think you can continue now.
Okay, thank you. So
you.
again, same box plot. We're just looking at gender against age, so gender distribution against the age. The only thing we are varying is just this, and these are just the two features. So it's pretty much the same code. You can just do copy and paste and slight modify, right? And notice that also the age distribution between the male and female also quite similar as well, with just some slight variation in terms of the range. Let's say the average age distribution, right? Can I continue?
Yeah, you can continue.
Yeah. So one more box plots. We want to see how much they're spending. Again, quite similar. So not much in terms of average spending rate between the male and female, not much difference. But then again, for the benefit of those who are separate online, let me just put that there. But all you varying, you just take each feature, you can do box plot and just vary them. So I don't think we want to spend a bit more time on this as well. It's pretty much the same line, but then we can do some scatter plots as well, where we can see the variation of the income against the age. So it's not looking at just the average income as well, but we're just looking at the scatter plot. We're familiar with scatter plots because we've done some linear regression, in simple linear regression in the past. So the S here is just simply size. So you can vary the S to see its impact on the graph. Just makes the size of the data point smaller or bigger. I prefer 150, while 150 looks decent enough. So we go with that. Then we notice that it sort of increases just slightly. It increases the income, average income for the age increases from 20, depends on the minimum age we've got, of course, but it increases slightly with just be up to about 40 or 50. And then it begins to drop after between 50 and 70. So the average earnings, so that's sort of the impression we get from this data set at that point. If you are still copying and pasting the box plot set of lines, please note this is a scatter plot, so you have to change that. The 150, you can't vary it, it just shows the size. That's what I was saying earlier. Just choose your preference. But I think 150 is way better than this. If you put, I don't know, 1000, you'll get something like that, which is ridiculous. Sorry. Can I continue?
No, please.
Okay, all right. Thanks for pausing me. Yeah, please, if I continue without asking, stop me as well, okay?
Yes, please. Thank you.
Like I said, you've had chocolate, I haven't. So we want to minimize the number of can I continues, otherwise you all ship chocolate to me.
I think you can continue now.
Okay, thank you. So we do the same. So we know the distribution of age against the income rates, and we want to see how much they spend as well. So basically, for now, we see that, well, the younger ages, there is between 20 and 40, there's actually significant increase in the spending score. As compared to around maybe 40 to 50, which is like more or less plateaued. Just an indicator, just rough estimates or just rough understanding of the data that we are dealing with, but at least it's kind of give us an overview of how our customers spend, right? So I do the same, and it's just only the these two that you are varying on there. Yes. Or only thing you're changing on there is spending score. I think with this, you're happy for me to continue now.
Yes, please.
Okay, so here is the thing. We are interested in looking at income and spending score, right? So as you can see, with the distribution of the income and spending score, it's quite similar to the graph that we drew earlier, where we had the low income against low spending, and we had high income against high spending, if you remember in the presentations. But if not, at least this one gives us an indication of the potential clusters we are likely to end up with. I think you can sort of see it or almost tell, like probably there's going to be one cluster, probably that's going to be another cluster. I don't know, who knows? Yeah. And it's the same scatter plot, but you just simply changing age to income, and then spending score still remains the same. Continuing.
Yes, please.
Yep,
Yes,
since
please.
someone has time to bring out their mobile phone, I can see that they finished typing, so I can continue. So our step 3, to prepare our data, right? So let's prepare the data for training the model. So basically for clustering. So this is a point where you're usually like, we're going to the point where we did some cleaning in the last video that we shared in class. But anyway, let's do some things now. So basically we want to describe the customer's data, and the describe actually just returns, we're on step 3 now, okay? The describe returns the numerical or the features with numerical values, right? So what we are trying to do is the numerical value that we're bringing back, we simply just want to round them to 2 decimal places, right? And we notice that it sort of returns some good statistics for us, or statistical values, things like the number of counts that we had, the mean of each data. We are interested in the income and the spending score, how much they earn, how much they spend. That's all we're interested in at this particular moment, right? And we've got a mean, and then we've got the standard deviation, we've got minimum, we've got other things that we can actually maximum value, minimum, maximum count for each of the features we are looking at. But one thing we notice, standard deviation is sort of average distance away from the mean, right? So standard deviation for the income is extremely high compared to that of the spending score. I think you can see we've got 262 something. It's a really high number. And another one is 25. And the way the K-means, our understanding of how the K-means algorithm works, it's mostly working with Euclidean distance, right? So if you've got a lot of outliers in this, but as you can see in this case, with the standard deviation, the income is likely to skew our whole clustering or to dominate the clustering rather than the spending score. So we won't have a very good indicator or very good clustering if we work with the data as it is. So the plan will be to normalize this. So, normalize, you just take all the data point ranges and then you try to find a range between 0 and 1, or between 0 and 100, or between negative. Just basically find a normalized feature, or just find a normalized range. So we are likely to end up with the same range for the standard deviation for the income and the same range for the spending, standard deviation for the spending score. Are we okay up to this point? So that's sort of our next target, right?
Yes, please.
Okay. Can I continue?
Yes.
Was it yes, or yes?
Yes, you can continue.
Right. Sorry, the is hard to interpret, right? So basically, we're just simply looking at scaling, right? That's what we're trying to do, right? And I said earlier, you can spend more time on a scaler and to see what is available to you, or Scatterplot website, to see what is available to you. Or you can actually learn more about them from Kaggle as well. So Kaggle will give you some some good machine learning resources for you to learn from, but can just go straight to the website. So from sklearn, we want to make use of the standard scalar. At this point, all we are interested in is simply trying to find a way of normalizing this standard deviation, right? So we take this standard scalar, and of course, we import it to a data frame called scalar. And from the scalar function, we basically want to call the fit method. And what we are trying to do is just simply fit the income and then the spending score on a normalized data for the standard deviation. Does that sort of make sense up to this point?
Yes.
Yes, please.
Okay. So if once we run this, we are likely to end up, I think I should have run each line, but anyway, because I changed the data set in mind, but we are likely to end up, well, this returns a matrix array for us. So it's just basically an array return for us. And we just want to present it in a data frame format. So basically we use the pandas data frame to basically just import the new normalized data we've created, so we can make use of it. So we have these customers, which we had before. Now we have the scaled version of the customers, and we do a describe again, just as we did 2 lines ago. Sorry, let me put this in the chat for those typing as well. Can I scroll up or down? Can I continue or pause?
What did you say?
Can I continue? That's what I said.
Yes, please. Sorry.
Okay, so scrolling up. If you are still typing, let me know. Right.
Still typing.
Oh, I said you were the one that said continue. Continue me scroll up, right? Okay. I'll pause. And for those doing the copy and paste on the side, it's still in the chat window for you. Remember, all we're trying to do is to just normalize the data. So we have a similar range for the standard deviation. So otherwise, we don't want the income standard deviation to dominate our clustering that we'll be doing, okay?
Why?
That's why it's good to look at the data to understand it. On continue. Sorry, those who speak French, I don't speak French, so I'm just making that up. I don't sound anything like correct. Can I continue? Still typing?
Yes, please.
Yes, please. Wait, what's up? What's the typing?
I think you can continue now.
Thank you. So basically, we just we do a describe again, round it to 2. Let me see, did I put that in the, yes, for the chat people online, on there for the chat. And we notice that once we are done with the normalization, we have the same range for the standard deviation. So like something reasonable now, right? So unlike what we had before, right? So everything normalized for us. Similar range, negative numbers, minimum, and everything. Good. So at least we've got similar distribution that we can make use of. Can I continue?
Yeah.
Okay. Right. Okay, so next step is sort of our main goal, right? So we want to create clusters. Yeah, so we want to create the clusters. And again, similar to the way that we imported regression from sklearn or scikit-learn, we want to import the k-means from scikit-learn. So we in scikit-learn or sklearn, just say scaling. We go to the clusters. Of course, we are dealing with clusters on supervised learning. Then we import the k-means from the cluster options that we have. And we just want to have a placeholder code. Of course, we have the k-means. Within the k-means, we get several parameters, right? So we choose the k first, which is the number of clusters. The number of clusters or the k that we want to start with. We just want to do similar to what we did before. The k that we have is 3, right? Yeah. And then we tell it how many times or how many iterations we want to have. It's statistical. So how many times we just wanted to attempt to create these clusters. We said attempt 25 times, for example. You can vary it to see what works best after you're done with the lab and you are playing with the activity a lot more. But basically at this point, we're just saying, try 25 times because we have these random placements. We've got all these things that we'll be doing at this point to create the centroids and all those kind of stuff, right? Sorry, I'll slow down now the pace at which I'm talking. And we will come back to, remember, we have the centers randomly placed. So if you are using random algorithm, normally you use a random seed. If you use the same random seed, it allows it to sort of recreate the same random numbers each time that's created or when we are repeating the activity. So we give it a random seed. You can choose, but we choose 1, 2, 3, 4 as a random seed in this particular case. Other people have more random ways of generating random seeds, so it doesn't really become perfect random if you want. Okay, so we're okay up to this point, right?
Yeah.
Yeah,
Yes.
then of course, once we're done, we want to fix the actual scale data that we have created, or scale data set, which is basically the ones with the standard deviation normalized, right? So we fit that and hope that it's created the clusters for us. I'm scrolling. Can I keep scrolling?
You're fine. Okay.
So then we notice that, of course, it's created the clusters for us where we have one group, one cluster 0, and then we've got others placed in, we've got a bit of it's like one fitting in the seconds, but the third but sitting on there, and then we've got the second cluster being 1, and then the third being 2 labeled here. So we've got some clusters sort of created for us. Yeah, just do a lot more we can do with it. All we've done is just basically created the clusters, and then we just want to see call the cluster label, so we see each item, which label they belong to, but pretty much same. Yeah.
Yes, please.
So scrolling.
Yes.
Who can give us a rough idea of how Wcss works?
Find the.
Wait, is that Kweku in the room, or is Kovna?
Both of them.
Both of them. Do we have more chocolate? So whoever answers it just get only one chocolate.
Is that okay?
Okay, all right. So go for it. Who can give us a rough idea of what the Wcss is or how it works?
What is WCS?
WCSS.
Within each cluster, it contains the
Let's see who was awake.
Just
Someone is coming to answer.
Someone is coming. Oh yeah. Say your name and go for it.
I think it's the sum of the distance of AI all squared plus the sum of the distance of BI all squared plus the sum of the distance of CI all squared.
So so it's within cluster sum of squares. Thank you very much. Sorry, you didn't say your name.
Her name is Leanne.
Thanks, Leanne. So basically, it's got within cluster sum of squares. So basically, you are interested in each item, how far they are from the centroid that is created within that cluster, right?
Yes, please.
Then you sum all of it. So basically, the first test we can do is just basically just take the clusters, and we want to print out the inertia, and the inertia is actually the Wcss for us. Yeah.
Yes, please.
Yes, please.
So,
Professor Michael, please, do people get different WCSS on the same?
likely, it depends on how you've created your clusters, remember? And also remember that the way the way these centers are placed is by random placement, right? So the centers are placed randomly. And that is why we're really trying to force the initial seed for the random function to be the same.
Okay, thank you.
Yeah. So if clusters are placed anywhere, you're likely to end up with slightly different WCSS. Can I continue? Sorry, I should run mine again.
Yes.
Yes.
Yeah, sorry, that's where we are. Because I played with my data at a different point in time. So around 150 something. Anyway, yeah, we continue. So the next step is so someone got a stretch chocolate. I do apologize. I just sort of pinched you off one chocolate. So the next step is basically evaluate and visualize the data or visualize the clusters. Would have been model in another one. Make life easy, copy it, paste in the chat for those who are online. So, right, basically we want to take each cluster and we want to sort of count the number of items within the cluster, right? So of course we have Panda, the data frame we already created as well, or we can just basically go into Panda query series, and then we have a look at the k-means clusters that we have created. Among the labels, we are interested in the labels at this particular point in time. The label is just basically the clusters we've created, which are cluster labels, and we want to count the values in each of them, the number of items. So we notice that actually the first cluster has a really large number compared to the others, and the others are quite close to each other, right? Cluster 1, cluster 2. Sometimes this sort of gives us an indication that maybe the K we have used is not the best K to use, because we've sort of resulted in an imbalance within the clusters that we have created.
Can you just repeat that?
Right, so in short, we're using this to look at the clusters we've created, right? And we want to count the number of items within each cluster. So we can actually use that line of code to visualize it now. But then if we look at the data distribution, right, you can tell that, yeah, cluster 1 and 2 are quite similar, but the cluster 0 in terms of numbers, number of items within the clusters is quite large. So we do have an imbalance, and it sort of gives us an indication that this K equals 3 that we used is probably not the best K to use.
Okay,
Sorry, was that too fast, or was it? Yeah, you said thank you. That means it's okay. Right. You are rocking.
Oh, sorry.
Okay. I tend to do that too, but when I'm tired, really tired. Okay, sorry. Yeah, at least I could see. Okay, so can we continue or everybody's okay? I see folded arms, it means not typing, means Michael can scroll up, right?
Yes.
Yeah, so then we get a way of also printing out the cluster centers so you can actually see the centroids. And of course, you see two numbers, right? These two numbers are just indicated the XY position of it, right? It's just Cartesian coordinates that you can use in terms of how the centroids are placed. Then we notice we've got some really low value for some of the centroids, like negative for especially cluster 0. So we start to get a feeling that, yeah, something is kind of wrong here because we are aiming for higher values for these centroids. But at the moment, we sort of have an indication that, yeah, cluster 0, maybe something is wrong there at this particular point in time. Right?
Yeah.
Yes, please.
So again, let me see if minimizes changes anything to this code. No, it doesn't, but just slide, oops. I don't know what I did there. Oh, there we are. Only thing there is a square and then a bracket. So let me copy that and paste it for people.
Okay.
Then I'll make it bigger in a second, okay?
Okay, thank you.
Make it big. Actually, I should be running each of these. Yeah, we are on point. So there we are. Sorry. So we want to see basically within each cluster, we want to also take the income and then also the spending score. And we want to print out the centroids for each cluster, of course, along with the labels. So we just did it here, but it's presented it as an array, and we are just exporting it to pandas. So at least we can visualize it properly, something like in a CSV layout. So it's pretty much, you see, it's the same output between the previous line and this one, but just making use of pandas to do that. And again, it's in the chat for those who are typing on there. Can I continue? You want me to go left or right? The bit you can see is just spending score and then a bracket to close this one and another bracket to close the other one. Okay, so I just make it like that. The person sitting closest to me, what's your name?
Adele.
So Adele is
Wait,
sitting
which one?
closest to the microphone, closest to the camera on the right-hand side, on the same row as Adele.
Yes.
Someone.
Yeah, Samuel, yeah, Samuel types really fast. So if I use Samuel to probably judge whether I should continue or not, people will still be typing. So I have to find somebody else.
I think you can continue.
Thank you. Because all along I was looking at someone thinking, oh, we can continue, but we can't. So this is where maybe the typing would take a bit of time, right? But just bear with me. I'll just copy it. Sorry. I'll paste it in the chat. Can I just do that? Oops, it won't allow me to because it's too much. I'll just copy it into small sessions and then I'll paste it in the chat. And this also the bit where it's just going to be repetitive from this. It's going to be repetitive code, okay? It's going to be the bit where maybe we just need to understand a touch of it because we want to find out what we are doing. And that's in the chat. And of course, Kwekwe and Kwabena have access to the code as well. They can share with you. But that I still really want you to print it out. So basically, we know that we can have access to the centroids and also we can have access to the clusters. We can have access to the data points. We just want to find a way that we can actually plot them. And remember, we imported matplot earlier, right? I'll just leave it there for you. So first of all, we just want to play with Matplots, setting the size of the figures. We've done this in the past, right? So in terms of figure size and other things, we even did some labeling of the axes and all those kind of things. That's just play, right? So, and we want to also get our hands on Seaborn, and then we want to find out, of course, the scatter plot, and we really want to just simply plot from the scale data, the income against the spending score, and we set in the colors and the labels and those kind of things. And remember, he'll allow us to put the one graph against another as well. We did the same when we were doing, I think, linear logistic regression in the past. Now, we've also made use of colorblind and other things. We've set size and all those kind of things. We just want to switch off the legends for now. So pretty much just playing with the figure or setting the figures for us and then importing the data. We okay with that?
Yeah.
Can I scroll or I should pause?
Please pause.
Okay.
No.
How is it?
No.
Okay, we'll type through this one. We'll get to a point where I'll just explain the remainder of the code, and then after the class, you can also work on a shared version of your code as well. But please go for it. Those who are logged in, the code is already available to you in the chat. If you also want to log in, I can transfer it to you now.
Is there?
No,
No, three.
I think we will so that we could- Mm,
Continue or stop. I know my voice is terrible, but I'm saying, oh yeah, I'm recording. Oh, no. Can I continue?
Okay.
oh my God. I think you I think you can continue.
Okay, good. Don't worry, we'll share this bit of the code with you anyway. Unless if you're already logged in, then it's also easy. So then we want yeah, we've played with this. So now we want to also plot, of course, the centroids, because the whole advantage of using the hue also. We want to plot the centroids, so we want to make sure that centroids also appear for us, and we do the same, right? Same code. Just copy paste and then do some modification, and you'll be fine. And make it big. Yeah, bit too big. Okay, with that. And of course, in your own time, you can change things like the marker, you can change the EC and all those things to see its impact on the graph. And then you build your own good practice for yourself. Or template, let me say. Copy, paste, modify fields, right?
Yes.
Can I continue? Yes, thank you. So then we also, of course, we just want to find the centroid labels. And remember, we printed the data where we put the labels of the centroid. We were 0, 0, 0, 1, 1, and everything. So basically, we are using for loops going through the cluster centroids, and we just really want to pull out the label for each of them. And we simply want to print it out as well. So it makes it nice and easy for us to play with. I think I've already posted this in the chat. We can breathe on a bit since this is our first graph, and then we see how the output look like. So plotted with code.
Are you sure? Because plotting the centroid is different. The data is clustered. Yeah, cluster is also. Small. So here it is clustered. Hey. Let's do from the beginning. It's fine. Changing. It's a string. School. If you learn the last one. There's an centroid.
I haven't written the I haven't Oh, look in this close. Making sure of the
Okay, can I continue? Good. I think we've done really well as a class by typing up to this point, and hopefully as you type, it goes through your brain and stay there as well. So at least not just the understanding, but some of the functions or libraries that we're making use of and how we're making use of them. But the remainder of this session, I'll just be explaining the remainder of the code. So when we share it with you, you see what is happening and you make your own deductions from it as well. So this is what our effort has created for us. Let me run mine. Probably a bad idea to run it. That's what I said. Lost it. I should run it for myself again. Where did I lose? What did I lose? What did I lose? Oh dear. Has anybody run it on their side?
Yes.
You managed to get a graph all right.
Mm-hmm.
And the Michael didn't get it. So it was there and it disappeared a few minutes. We go back to it and work with it at some point anyway. But if you see your graph, you see that the centroids has been created and well, the clusters have been created with the centroids placed in them. Yeah?
Yeah.
Okay. Because of time, for the sake of time, I'm not going to bother about the error on my side yet because we'll still be seeing them again at some point on here, right? I'm just going to, bear with me. I'm not going to try to run any code again, but at least I'm going to walk through my code so you see it. So basically that helps us to visualize the center. And I think you see that one of the clusters, the cluster 0 is a bit too big, right? So then we say we are interested in looking at the within cluster sum of squares. Before we use the inertia to view the within cluster sum of squares. So what we are doing at this point is just evaluating and trying to choose the right number of k, right? So we've got some lines of code which I'll copy across. Already we know how the WCSS work, right? So we've got a range of, well, we're using a for loop to go through, let's say, 2 to 10, and we want to find out for each cluster with the same as we did earlier, where we use 3 as a fixed K to run to try to create a cluster 25 times iteration with a random seed fix. So we're just using the same, but in this particular case we are varying the value of K, and again we fit it, but we are fitting it, and we are of course interested in the inertia. So basically just using the within cluster sum of squares, and then we plot it out for each of them running down. If you want me to slow down, go step by step, let me know, but I'm sure this side we are okay with it, plotting the figures and other things. Then we notice that once we vary the number of Ks and we do our plot, the best K is around 5. That's where we have our elbow. Are we okay with that? Or it looks like a jump? Good. I see hand up. I see the thumbs up. So it means it's a good sign. Then there is, of course, the Kalinski-Harabar score, and also there is the average celluloid score as well. Not square. Why would I say square? So, right. We do something similar, but in this particular case, we are also looking at the Kalinski-Harabar score. Why do it? I should be able to say that. So we import it from scikit-learn and as a metric, and then we just simply make use of it here. So it's similar code as what we saw for the WCSS, which was here, but in this particular case, we are importing the Kalinski-Harabar score. So just as a library that we are using, and we do the plot for it as well. And again, you see one thing, remember what we said about this. This is the one that we are actually comparing each centroid with the mean centroid or the average centroid. And then also we are looking within, looking at the WCSS as well. And we're doing the BCSS divided by WCSS multiplied by n-1 and all those things. So we notice two points that we can make use of, the highest point and then also the first peak or the first spike there. The first spike is around 5 and the highest point is 10. Which one would be the reasonable number of K to use? Someone's giving me an indicator. Let's see what they say. 5 as well. Yes, we all agree. So we go for the one with the first spike. Good. We are on point. We are on track. So let's see. We've got 2 that tell us maybe they give us an idea of the right K to use. You can choose to stop or be like me, be paranoid, go a step further. So we import the silhouette. Blame it on my accent. Right. So we import the silhouette and then also the same similar code as we had before, but we are making use of silhouette now. So it's pretty much the same code with slight adjustments. Sorry, am I talking too fast?
Yes.
Yes.
Probably shouting, nobody paused me. But unfortunately, I don't know how to sing to you. Can tell. All right, if I sing, probably the microphone will break. Okay, so sorry, do we understand up to this point?
Yes, please.
Somehow.
Somehow, please, somehow.
Yes.
Okay, right. If you need, you remember where we started from. We started by evaluating the right number of K. These lines of code are repetitive. You're only just changing the function we're using in this case. So we want to look at the silhouette as well, which is where we take each item and we look at its distance from other items within the cluster and also from other items within other clusters as well. So once we make use of that, we have this graph, this auto-generated. I'm only skipping that part to this because it's similar to the 2 that we've described before. Are we okay?
Yes, please.
Yes. So once we plot it, which point do we go for as the best number of K? Are we looking at the last point, which is sort of at the minimum of the slope, or are we looking at the minimum value, or we are looking at something else?
The peak.
we're looking at their peak, and the peak in this particular case is 5. So we realize that for all the techniques we have tested with, the best K to use is 5. Then we make a decision, we go back to create the clusters again, but this time using a K value of 5, right?
Yeah.
What do you say? Yes. The rest, pretty much the same code, really, same code. Now we see that number of clusters created for us, more than enough, same code, but we come back and we have 5 clusters created for us this time. What you would have noticed is that I think before this was like cluster 0, it was really large and it's been split into 0, 3, and then I think it was probably 4 or something like that. But at least this distribution is quite similar to, sorry, I'm scrolling too fast for those who it's quite similar to that distribution on there. If you don't see it, there it is. So we've managed to recreate and create our clusters with a K that best fit for us. If you are happy up to this point, I'm happy for us to wrap up at this point. But when you practice the lab on your own at home, I want you to make the analysis, right? Which kind of customers are you likely to target forward, right? Remember, we've got low income, low spending. We've got high income, high spending. That's the distribution, low to high, low to high on that side as well. So I want you to make some inference based on this, and also make some inference based on age as well. I'll probably make just some short video recording, maybe no need, but you see the code once you complete your side, and then you let me know what is happening. All good?
Can you repeat, please?
So once you finish your clustering, I want you to sort of make some analysis, how to target these customers. We've got a range of low to high income earning customers, and then also low to high spending customers, and we've grouped them into clusters. So you need to make some analysis or some decisions based on that. Yeah?
Okay.
It's quite simple. Everybody has the same code, just your own analysis of it. And I think we are on time. We were in time, onto the question. But then I'm happy for us to end here. If you are.
Thank you.
Okay. So
Yes.
you get a sample code with some extra. Please practice.
Yes, please. Thank you.
Thank you all so much.
Prof. Michael.
Thank you. I'm
Prof.
still
Michael.
jealous of the chocolates. You can talk, but I'm jealous. So I will tell the whole class.
Prof. Michael.